Welcome to our lesson on arithmetic progressions, also known as AP. Let's learn what these sequences are and how to work with them. An arithmetic progression is a sequence where each term after the first is obtained by adding a constant value called the common difference. For example, the sequence 3, 7, 11, 15, and so on is an arithmetic progression with first term 3 and common difference 4. Let's look at the general form of an arithmetic progression. If we denote the first term as a sub 1 and the common difference as d, then the sequence follows this pattern: a sub 1 plus d, a sub 1 plus 2d, a sub 1 plus 3d, and so on. We can see the pattern clearly. The general term, which we call a sub n, equals a sub 1 plus n minus 1 times d. Let's visualize this formula with a diagram. Here, we have a number line showing an arithmetic progression. Each step moves us exactly d units to the right. To go from the first term to the nth term, we need to make n minus 1 steps. So the nth term equals the first term plus n minus 1 times the common difference. Now, let's learn how to find the sum of the first n terms in an arithmetic progression. For this, we use a clever trick attributed to the mathematician Gauss. We'll write the sum twice, once in increasing order and once in decreasing order. Notice what happens when we add the corresponding terms. Each pair sums to a sub 1 plus a sub n, and we have n such pairs. This means our sum equals n divided by 2 times the sum of the first and last terms, or mathematically, s sub n equals n divided by 2 times a sub 1 plus a sub n. There's another useful form of the sum formula. Since we know that a sub n equals a sub 1 plus n minus 1d, we can substitute this into our sum formula. This gives us s sub n equals n over 2 times 2 a sub 1 plus n minus 1 times d. Let's work through an example to see how these formulas are applied. Consider an arithmetic progression with first term a sub 1 equals 3 and common difference d equals 5. First, let's find the fourth term. Using the formula a sub n equals a sub 1 plus n minus 1d, a sub 4 equals 3 plus 4 minus 1 times 5. That's 3 plus 3 times 5, which equals 3 plus 15, giving us 18. Now, let's find the sum of the first 4 terms. We can use the formula s sub n equals n over 2 times 2 a sub 1 plus n minus 1d. Substituting our values. S sub 4 equals 4 over 2 times 3 plus 4 minus 1 times 5. That's 2 times 6 plus 15, which equals 2 times 21, giving us a sum of 42. Let's verify our calculation by writing out the terms and adding them directly. The first 4 terms are a sub 1 equals 3, a sub 2 equals 8, a sub 3 equals 13, and a sub 4 equals 18. Adding these up, 3 plus 8 plus 13 plus 18 equals 42. This confirms our result. Arithmetic progressions appear in many real-world situations. For example, if you save $10 the first month and increase your savings by $5 each month, you're creating an arithmetic progression. After 1 year, your sequence would be 10, 15, 20, and so on. The sum formula helps calculate your total savings much faster than adding each amount individually. To summarize, an arithmetic progression has a constant difference between consecutive terms. The 2 key formulas are the nth term formula, a sub n equals a sub 1 plus n minus 1 times d, and the sum formula, s sub n equals n over 2 times a sub 1 plus a sub n. These tools help us efficiently calculate values and sums in any arithmetic sequence.